All right, so where we left off, we were going to use the outputs of our NAND gate to connect to the presets and clears to go to the first number of the count. And we said if we're going from 3 up to 5, our first number would be 3. If we're going from 5 down to 3, our first number there would be 5. If we were going from 6 up to 15, our first number is 6. If we're going from 15 down to 6, our first number is 15. I think you guys get the idea of that. So we figure out which number we're going to. Next, we want to write it in binary. So our example here, our first number we're going to is 3. So that is 0, 1, 1 in binary. So the zeros, that is our most significant bit. This last one is our least significant bit. Zeros imply that we're going to be connecting to a clear, and ones imply that we're going to be connecting to our preset. So 0, 1, 1, if we come back to our thing, we're going to be connecting to 0, 1, 1. Notice, most significant bit down here, least significant bit up there. So we're going to be connecting to 1, which is our preset. We're connecting to 1, which is our preset, and connecting to 0, which is our clear. All right. Now that we've finished that, the steps actually get a lot shorter and a lot faster here. So step 4, we need to power any unused presets and clears. Because if they're not powered, then the state of them is just floating. It could be a 0, it could be a 1, and it could mess up the circuit. So we used the preset here. The clear is unused. We're going to connect it to power. Same thing on this one. On the bottom one here, we used clear. So our preset is unused. We'll connect that to power. All right. And the very last part of this is that Q's go to outputs. So if I was, say, going to run this into like a DCD hex or something like that, this is my least significant bit, so this Q would go here, this Q go here, and this Q go there. Since I only have a 3-bit number, that's all I'd have. Or if I was going to use like a binary to 7-segment display converter, I'd put that in there. Whatever you're going to hook it up to, that's where our outputs come from, is from those Qs. All right, so that's how we create a bounded synchronous counter.